Curious about the structure perhaps of the course. I think it's similar to chemistry. So for example, in chemistry, what were you told the end of semester 1 exam is worth? How many percentage points do you remember? 10, good. And how much is your lab?
10 also.
10 as well. And your essay?
10.
It's exactly the same. And the final exam for chemistry?
17.
And is for physics as well. Okay. In physics, there's 6 sections to the course. 3 in semester 1 and 3 in semester 2. We will start with mechanics, and then we'll go on to electricity, and then materials, and then fields and waves and atoms. But we don't have to worry about that, because we just need to worry about the first topic, which is mechanics, which is what we're going to start with today. Does anybody know this word? Well, I'm sure some people know this word, mechanics. Does anyone know? So what exactly is mechanics? What's maybe another word for mechanics?
Machines.
Machines, yeah. Like mechanical. Anything else? What else could we say about mechanics? Like what type of physics would be in mechanics, do you think? Motion, yeah. So who do you think is important for mechanics? Pretty important for physics. He comes from he's more later stuff, for hard stuff, for simpler stuff to begin with. He liked apples? Yeah, Newton. Yes. So really the first part of the course, the mechanics, is a lot about Newton's work. Force, mass, acceleration, speed, things like this. But don't worry about that. We're going to deal with it bit by bit. So, physics. I don't like this. Why is this here? This shouldn't be here. Delete everything. Okay. Physics. Hopefully the problem will go away if I don't look at it. Alright, so all you need for the class is just pen, paper, calculator. I print out the stuff as we need them, and the lessons are recorded and they'll go up on YouTube as well. There are books in the library if you want to use books, but you don't need to bring a book to class. I think for chemistry you have something printed out as well, don't you? Yeah. I just printed out the first 2 for today, but in the next class I'll print out the full book so you can have all the questions for semester 1. But for today we'll just do the first 2, is all I had time to print. Okay, so you might want to write this down. This is what we're going to start with, units and dimensions. I'll get your names now in a second. Right, you got pen and paper, yeah? Let me just get some names. I know you probably told me, but I forgot. Audrey? I think I can remember that. Rowand? Yes.
Darius.
Darius?
Yeah.
Kelvin. I'm not going to forget that. Kelvin. Leo? Is that okay? Yeah? Okay. Leo, Calvin, already forgot.
Darius.
Darius. Rowan. Audrey. Yeah, okay. Alright, that's alright. Okay. Units and dimensions. Did you write that down? I don't think these are words you might know. Well, maybe somebody knows them. Does anybody know units? This word? Yeah, what would you say a unit is?
Centimeters.
Yeah, these are all units. So if there are units, what's dimension?
3D, 2D.
True in general English, but something a bit different in physics. Does anyone know this one dimension? But anyways, let's have a start. So, just so you know, I have all the slides here. You don't need to write every single thing down. You know, make your own notes. I will tell you the really important things. So we'll start off with a unit. Now, hang on. I wonder if that's... no. A unit, well, you just told me an example of a unit. Centimetre, metre, and so on. A unit is a system used to measure a quantity. So what I mean is, I'm not expecting everybody to write this sentence down. Like, I mean, you could even just say, you know, unit, measure, quantity. You know, I'm just giving you some basic words in this slide. We have 3 what we call fundamental dimensions. They are length, which is, you know, how long something is, mass, and time. These are like the 3, what you might say, basic dimensions: length, mass, and time. Okay, so, for example, the metre, that's the unit, we use that to measure length. What would we use to measure mass? Kilograms, kg, yeah? And what might we use to measure time? What unit? Second. So, units measure a dimension, okay? Other dimensions exist, but you can make them from these basic 3. So as an example, this is the physics class. Where's my cappuccino?
They didn't tell us.
No cappuccino, no pastry. You are the worst manservants ever. Go sit down back. These are 2 of my previous success cases I had from last year. They're off studying mechanical engineering and biomedical engineering. Have a look at them. One day you could be just like them.
You tried to do
Anyways, what's your plans here? You're going to get some units and dimension revision and then...
No, we're just assessing your class.
Oh good, okay, alright. Let me know afterwards how I do, okay? As I was saying, we can make other units and dimensions from these fundamental ones. For example, area is length squared. And what about volume?
Meter.
Yeah, but using the 3 basic ones we have, length, mass, and time, what would volume be? Length cubed. Okay. The size, or how much of a unit we have, is called the magnitude. So you'll need to note that word. Magnitude means size. So you should definitely write that down. Want to take any notes?
No, I ever do.
Just this one time for me. I should actually quiz you to see how much you remember. Yeah. Because we're going to do the 7 basic units. We'll see how many of them you remember. Okay, alright. Okay, continuing. So we have the International System of Units. These are the basic units we use to make measurement. And there's 7 of them. And the students down the back are going to tell me the 7 basic units. Get off the phone, you don't need to look it up. What are the 7 basic units?
Length, time, light intensity.
Okay, no, you're mixing up units and dimensions. I just want the units.
Okay. Meters.
Yes,
Seconds.
yes.
Joule. No.
Two.
I just said two.
Yeah,
Kilogram.
yes, that's three. Getting closer.
What's the light intensity thingy?
Anyone else know any? We have meter,
Yeah.
seconds, and kilograms. What else is there? Amp, yes. Yes. Let's have a look. So, we start off with the meter. And what does meter measure?
Length.
Length, which measures length. Next, we have the kilogram, which measures mass.
No.
Yeah. And the second, which measures
Kelvin.
time. There we go. We also have the amp.
Yeah.
What does the amp measure? Current, good. Yeah. The Kelvin, which measures Kelvin measures temperature. Yeah. The mole, which measures what?
We can't answer all the answers.
No, that's okay. You can't. 3 was enough. Yeah. The mole. Do we know what the mole measures? No. I don't know. What was your first chemistry lesson? You had chemistry? Yeah. You probably didn't do. Did you do moles yet? No. Okay. So the mole measures simply just how much you have of something, just the amount. And finally, the 7th one we don't actually use on this course. The last one, well, I know you said it earlier, but I wonder if any of these guys have heard of it before. There's one more left. It has something to do with light. No? Okay. Any ideas? No, I don't think you studied it. The last one, did you study it in high school, or just you only saw, you did see it before? The last one is called the candela. And what does that measure?
Light intensity.
Yeah, measures how light, how intense light is. So it's sort of like a brightness. Yeah. So what you need to write down is the units and what they measure. Okay, these are the 7 base units. How many people here studied physics in English? Okay, so these are familiar words, yeah? And Kelvin is new, except for Kelvin, they're all new words, are they? Or some of them are new, yeah. And for you, did you study this in English? A mix. So how many of these are new words? Have you seen all 7 of these before? The last one?
Yeah, the last one.
Yeah, candela, okay. Okay, not yet. Brings back memories? Okay, are we nearly got that yet? Continue? Yes? Alright. So, if quantities have the same dimension, you can compare them or equate them. What that means is you can see if one is bigger than the other or if they're equal. So let me just perhaps put that down with an example here. So if A measures length and B measures length, for example 2 meters and 3 meters, you can compare them. You can say one is bigger than the other. It doesn't really make sense to say 2 kilograms is less than 3 kilometers. You know, I mean, this is totally wrong, but this of course is okay. So the first rule here is if they're the same dimension, you can compare them or make them equal if you want. The second rule, if they have the same dimension, you can add, subtract, multiply or divide them, obviously. So you're allowed to do this. That's allowed. If they have a different dimension, you cannot add or subtract them. What about if they have a different dimension and you want to multiply or divide them? Can you do that or not do that? What do you think? So you're saying you can, yeah. You can. It's fine to do this. 2 meters multiply 3 meters. Or I should say perhaps 2 meters multiply 2 seconds. You are actually allowed to multiply and divide by different units. So the last rule here is if they're different dimensions, you can still multiply or divide them. That's allowed. These are sort of 4 basic rules. You don't need to write down every word, but just write something down for this, please. Okay, so if they're the same, we can compare them. If they're the same, we can add or subtract. If they're different, we cannot add or subtract. And if they're different, we can multiply or divide. How far in physics did you go in semester 1? What was the most advanced topic? I mean, are you still doing mechanics? Yeah?
Thermal heat expansion. Oh, yeah, with
Materials? Yeah.
capacity,
That's
that's it.
it? Any electricity?
Yeah, we have the subject.
Oh, that's a separate subject. Okay.
Nothing after V equals IR.
Nothing after V equals IR.
Either.
Just answer me this, Kirchhoff, yes or no?
No, we didn't do. We did something else.
We did Wheatstone Bridge and what was the other thing?
Stonebridge is something that's in between Kirchhoff and
We didn't do
Ohm's law.
definite theorem.
Yeah.
No Kirchhoff, huh? Okay.
Exactly.
Why even bother going to class?
I know, right?
Okay, you got this? Yep. Alright. So, let's just check this out. We'll do these together. Which are valid and which are not valid. So, the first one. Can we do this? Is this valid or not?
Yes.
It's okay, yeah. The second one, 5 meters is bigger than 2 meters.
Yeah.
That's okay. The next one, 2 hours is bigger than 1 kilogram. No. X is 3 kilograms divided by 2 meters cubed.
Yes.
That's okay. 5 meters plus 2 kilograms. No. 5 meters multiplied by 2 kilograms. Yes, this is all okay. Good, okay. Right. What are the dimensions of each of the following? X is length. M has a mass. So the dimension of X is length and the dimension of mass of M is mass. So what is the dimension of each of these? So I'll let you try these, but I'll just get you started with the first one. So for example, X here is length. That means we know what Y should be. What should Y be? It has to be length. Why? Because, well, we're adding. Which means we know what Z must be. Must also be length. So we know what X plus Y plus Z must be.
Length.
It must also be length. So in other words, by me telling you that X measures a length, that's enough to know that all of these must be a length. and it means, whoops, that W is a length. Yeah? So I'll just give you 1 minute. I want you to write down what the dimensions for these 4 letters are. W, A, V, and rho.
Are you recording?
I am recording. Why?
Do you know that they're being recorded?
They know. I told you you're being recorded, aren't you? No? You're not being recorded. This is being recorded.
And the voice exposed.
Oh yeah, like and subscribe to my channel, please.
Did you hit 100 yet?
I'm at 215 subscribers.
Whoa.
There you go.
214.
Yeah, so the next target now is 300.
What's the video of you?
It's not even a maths video. I show a video on how to install a program I made to let you watch Irish
On a
television.
thingy,
Yeah.
yeah, the thingy.
It's like 14,000 views.
It's in there. How to hack the satellite system so that you don't pay your TV bill.
That's actually true, but I didn't say that in the video. You're going to have the students thinking I'm some kind of hacker. Oh!
No.
You know what I added to my phone?
Yeah.
I can check the bus and the Lewis and the train times.
Upgrade. The phone's still alive.
See, the last time they were here, I could only check the bus times on my phone. Isn't that good?
Barely.
It's not an Android or an iPhone.
Better. Jealous much? Okay, have we got the answers here? What's the second one? What'd you say that is? Yeah? Not quite length. For this one? This one is length. That's definitely length. What about the second one?
There's the Y.
Ah, yeah, but you know what the Y is because it's from the last one. Yeah. Yeah. So, what would you say the dimension is?
L squared.
Yeah, length squared. Yeah, length squared. So the first one we said was a length. And the second one was a length squared. And this one? Length cubed. Yeah. And the last one? What's that one? How would you say that one? What's this on the top? Mass?
Mass over mass per length.
Yeah, mass per, not length, mass per length cubed, which we can write like this for the moment. Yes? For the moment. Okay, you got those? So the next part is I just want to know what is the units. Well, we can just write the answers down together. So if the first one measures length, what unit could we use?
Meter.
We can use the meter, and then meter squared, meter cubed, and then this one? Kilogram per
Meter cubed.
meter cubed. Okay, so that's fine. So this last one here kind of leads us into this, our first definition, something called density, represented by this letter rho, and it measures how much mass we have per unit volume. So as a formula, that's just simply mass over volume. Anybody give me in simple English what density is? So could you simply explain what density is, but maybe even with an example? Anyone want to try? Yeah. Yeah, but it's not quite, like, it's a little bit different.
Like a
You can't answer. If they can't, I'll let you. Go on.
like a cork on the water.
Yeah, what about it?
The density of the cork will float because its density is lower on the water.
Yeah, that's it, yeah. But what is density?
Is this how fast the molecules?
That's what I'm looking for. It's kind of like how packed it is. What were you going to say?
Not that.
Oh, sorry, I wanted the right answer. I should have said that. How packed the molecules are, as you put it. So, something like you were saying about the cork, the wood, it's not as tightly packed as the water, so we say it's less dense. Anyways, density is mass over volume. The dimension is mass per length cubed, which we can write like this or like this. And the units, of course, are kilogram per meter cubed, which we can write like this or we can write like this. So I think you should write all of this definition down, please, everything in the box. What classes did you have this morning?
Chem and math.
Yeah, chemistry and maths then, okay. So, chemistry was just basic introduction. What did you do?
Atoms, elements, introduction.
Just the names, atoms, protons,
Yeah, and just
stuff like that, okay.
Are you not teaching notes this year?
No, it's the literature.
I can't teach everything. Some
You
limits.
did.
No, they don't have me for
You
maths.
lost your touch.
They have another
Yeah.
teacher for maths. What?
You lost your touch.
Yes. Yeah, well, I know how I lost it. It was through stress. Okay, we got this? Yeah. What?
I was copying you.
Okay. Now, we will not use the / notation. This is not used anymore. Instead, from now on, we'll just use this minus notation. Okay. I don't know what you used in high school. So, for example, in high school, some people maybe wrote this, and some people maybe wrote this. So, which one did you use in high school? The left or the right? The left. Okay, which one did you use?
Right.
Okay.
Right.
Okay.
Left.
Oh,
Right.
okay. So we don't use this one. It's never used in the exam. Okay, and they don't expect you to write the answer like this. They expect you to write the answer like this. So try your best to remember to use this notation. Okay, just try to remember that. Most modern physics books will use this. Interesting. What did you use in semester 1 in Galway?
They didn't care about it as much as I, so I used that one anyway.
Yeah, but when your lecturer wrote on the board, do you remember which was used more?
I think it's
Yeah.
like,
You see, the difference is there's a bit of, this would be older usage.
Our lecturer sound was more than as you.
Bit old fashioned, yeah? Yeah. Okay. So here's a little question to get us started here. What is the density of water if 1 litre of water is 1 kilogram of mass and 1,000 litres make 1 metre cubed? So I just want you to calculate the density. I just want you to practice using the formula. It'll only take you 1 minute. So can you try and give me the density of water? I've given you all the information here. I didn't tell you my adventures with this phone. I tried to buy a cable for it to connect it to my computer. Then of course they don't make it anymore. So I had to find a used one in the UK. Cost me like £10. But that was the cheapest one I could find because they're usually sold on eBay for £30.
Why?
Because it was never sold with the phone. So the only few that exist are the ones that people actually bought when they bought the phone 10 years ago. Yeah, and then I tried to connect it to my computer and I didn't have the driver. So I only bought the cable, not the CD. And the CD that came with the cable had the driver on it. So now I need to try and find the CD with the driver for the cable.
What more do you want to program on your phone?
Because if I have the cable, I can change more about the phone.
Yeah, I know. What more do you want to change about it?
I want to post. I want to post to Twitter directly.
Okay.
And I feel like I want to control something with my phone as well. I don't know what. If I can remote control something, that'd be nice too. Yeah. Okay, how are we doing for this one? I don't think it was too hard. Have we got an answer? Yeah. Any answers for this one? What's the density of water? Did we get an answer? 1,000 what?
Kilograms or meters.
Yeah, that's it. So look, this is what I was picturing you might do here. Density is mass over volume. So you could look at 1,000 litres of water. If you had 1,000 litres of water, what's the mass of 1,000 litres of water? 1,000 kilograms, because I said 1 litre has a mass of 1 kilogram. So that's 1,000 kilograms. And the volume of 1,000 litres, well, I said 1,000 litres is 1 metre cubed. So that's 1 metre cubed. So the answer is 1,000 kilograms per metre cubed. Yeah? Is that okay? That was just something short to get started with. But of course, in real life we'll need to use bigger or smaller units, which we can make them bigger or smaller by using a prefix, some which you already know, like centi and milli and kilo. These are all prefixes. So, let's see which ones you know. Let's start with a big one. What's a big prefix? What's the biggest one you know? Bigger than kilo. Think about your computer. Tera, yeah. Tera, and what else?
Mega.
Mega, yeah. What else?
Giga.
Giga, yeah. So for this course, for the exam, I think we just need to start at Giga. Although you already know the one after Giga from your computer, it's Tera. So Giga, what letter do we use for Giga? It's a G. And how many zeros? How many zeros? Yeah.
9.
Is it?
It's 10 to the power of 9.
Yeah, it is. Yeah, yeah. Is that what you were saying? Yes. It's 10 to the 9. In English, what word is for 10 to the 9? If you have one with 9 zeros, what's that? Say, yeah, which one? Yes, very good. Billion. Okay, so that's Giga, that's the first one. Let's make it smaller. What's smaller than Giga? What's the next one? Mega, letter M, and it's how many zeros? 6. Okay, so you should be writing all of this down, yeah? And what word in English is for this number? If you have, what is it? Million, yeah. Good, okay. What is next? What is before mega?
Kilo.
Kilo, what letter?
K.
And how many zeros?
3.
What's up with you? Huh? Okay, now again a little bit harder. What's before kilo? We don't actually use hecto. So give me another one.
They can't.
And we also don't use deca.
They see.
So the next one then. Sentai. Yeah. For the exam, I'm only giving you the ones they expect you to know for the exam. Of course there are other ones too, like deca and so on. And it's great if you know them, but for exam purposes, these are the ones you need to know. So what letters for Sentai? C, and how big is it?
1.
Yeah, 10 to what power? No,
One.
no. -2, because it's that much. Yeah? Yeah. Okay, what's next after Sentai?
Maybe.
Very good. Letter?
Smaller.
Yep. And how many? 10 to the what? How many zeros? 10? Yes, -3. Good. Right, what's next after Millie? What letter? Yeah, what's that called?
Is it
Did you say alpha?
No, I said no.
Yeah, what letter is it?
like an
So you with a...
Yes, what is it called? I know. I believe you know the shape. Do you know the name?
I can Google it.
Somebody must know the name of this letter.
Oh.
No? It's Greek. Greek letter? No?
what is that? That's an M?
It's an M.
Oh, okay.
Oh, come on, guys. You don't know this one?
I do, my mom.
Mu.
New.
10 to the what power?
-6.
Yeah. And lastly, after micro,
Nano.
nano. Letter? And yeah, 10 to what power? What power here? -9. Yeah, nano. These are the ones you must know for the exam. Okay, you must know these ones for the exam. Okay, continue. You have this? Yeah. Right. So, you probably remember me saying this to you as well. Some of you learned very bad ways in high school for how to convert between one unit to another unit. And you should forget this way. I'm going to show you the way I would like you to convert things with an example, okay? Some people have picked up really bad high school habits on how to convert between units. So I'll just show you one way which I think is useful for converting. So as an example, I'm going to convert 50 kilometers per hour into meters per second. Okay? And a mile is 1.61 kilometers. So let's write this one down together. So I have 50 kilometers per hour. Oops. This is how I want you to convert. So first I'll just change this into 50 km over an hour. Now just remember what we're trying to get to. First meters per second and then miles per hour. So we'll do meters per second first. So I'm trying to get to meters per second. So, okay, that's nice that I have the meter. That's all I have. I need to get seconds into this. Well, if we look here, on the bottom we have 1 hour. So if we just think about how big an hour is, it's 3,600 seconds. So what I've done is, I've changed that into that. Okay? Now, what about the km? Well, what I find really useful is we can think of the k as just being a number. All the k is the number 10 power 3. That's all it is. So what I've done is I've changed this into 50 multiply 1,000 over 3,600 meters over seconds. And that gives me everything I need. So if you just take out your calculators and put this in, well, let's simplify this. Those two can go with those two. So that's 500 over 36 meters per second. Do you have calculators? Yeah. Do you have calculators?
We're waiting for them, you ordered them.
Per service, huh? Yeah. Right. 13.9 meters per second. Okay, that was kind of an easy one. Let's look at the harder ones, the miles per hour. So that was like part 1. Now let's do part 2. Are you ready if I continue? Yeah. So we have 13.9 meters per second, and I want to change this into miles per hour. Okay, this is harder now, because now we don't have anything that matches. There's no match. We have nothing in common. Okay, so let's see what we could do. Well, this is 13.9 meters over seconds. So we'll just say 1 second here. Okay. Now, if we go back to my notes or my question here, I said that a mile is about 1.61 kilometers. So I should try and get this into kilometers. So here's the thing. I could put a K here, but of course I can't just put a K there. What would I have to do to balance this if I put a K on the top?
Divide by 1,000.
Yeah, I'd have to divide by the K, the 1,000 as well. So now I have kilometers on top, which is good, and I have this kilosecond on bottom, or rather, perhaps I'll just say 1,000 seconds on bottom and km on top. Okay, so that's getting better, but I still need to get to miles, and all I know is a mile is 1.61 km. Okay, so what I could do here is just look at my 13.9 and divide it by 1.61. So what's that, please? .63. Okay, so here's the little trick you could do here. You could change that 13.9 into 8.63 multiplied by 1.61. Now you might say, why bother changing this one number into two numbers? Well, because if you look at the back here, what have I now made? What's 1.61 km? It's a mile. A mile is 1.61 km. All over 1,000 seconds. Okay, so now I can say this is 8.63 miles over 1,000 seconds. This is getting better. Nearly there. What do we need to change? What's the last thing to change? We're trying to get to miles per hour.
Seconds to hours.
Seconds to hours. Now, I have 1,000 seconds. How many seconds would I need to make it an hour?
2,600.
3,600. So, if I multiply this by 3.6 and this by 3.6, on the bottom I'll get 3,600 seconds.
Just an hour.
Which is an hour, yeah. And then on the top, what's these two multiplied? 8.63 times 3.6.
31.1.
31.1 miles. Now, as you said, 3,600 seconds, that is 1 hour. So this is 31.1 miles over 1 hour. Or that is 31.1 miles per hour then. Okay, so it's one way. I'm trying to get you into the habit of being able to change these as if they were like algebra terms. You know, for example, if you had an x squared here and an x here, you're free to do this. You know, I kind of want you to think the same way about the units. You know, if you had a kilometre here and a centimetre here, what can you cancel? Yeah, what can you actually cancel here? The metres actually cancel. And you're left with 1,000 over 10 to the minus 2, which is 10 to the 5. No unit anymore. I'm just trying to get you comfortable to treat these units as if they were like, you know, maths terms that you can just manipulate. Like what I did here, you know, that's something you might do in maths class. Yeah. Write that down if you need to, and we'll go on to another example now. Actually, let's just, yeah. Now we should check our answer makes sense. So if we go back to the start, do you think 50 kilometers is about 31 miles per hour? Yeah, that sounds about right, doesn't it? Yeah. I know you don't use miles, but you have a rough idea, right? No? I'm sure GTA uses miles per hour, right? Who? GTA?
Oh, okay.
Yeah.
Not sure.
Weren't really looking at the speedometer when you were
No.
ploughing down pedestrians, was it? Yes.
Isn't that straight?
Okay, you got this? Oh, sorry, now you got this nearly? Yeah, how far down are you? What are you writing?
Just a second.
Yeah, okay. Right, let's have a look at another example now. Yeah? Well, I suppose if you miss it, you can watch the video later then. How far are you? Okay. Right, here is actually a harder one. 50 centimeters squared into meters squared. Now the reason I say it's harder is because there's something a bit different in physics than in maths. So in maths, if I wrote AB squared, where's the square? Is it on the A, the B, or both? It's only on the B. Yeah? And if I wanted to show it's on both, what would I write? I'd have to write the AB like this in brackets. Then I square it. Okay? This is a little bit different in units. Okay? When I write cm squared, in fact, the square is on both the unit and the prefix. So actually cm squared is actually this in physics. Okay? Now if you remember that, it makes this a lot easier to do. Let's do this one together. 50 centimeters squared into meters squared. Okay, so let's do this one together. 50 centimeter squared. That's equal to 50 cm squared, like that. How big is the c? This centi? Yeah, it's 10 to the minus 2. It's this much, yeah? Which is that. Okay, so far? And that's 50 times 0.01 squared meter squared. Yeah, so that's 50 times 0.0001 meter squared. What's that now? 5 times 0.001 meters squared, which is 0.005 meter squared. Now, the opposite is a bit harder, going back to centile. Yeah, it's the last example. Okay, continue? Yes? Yeah. So, let's see about how to go backwards. Let's imagine I started with this, and I want to go back to centimeters squared. Much harder. What could I do first? I'm trying to get to cm squared. So I start off with 0.005 meters squared. Okay, so what can I do first? Any ideas? Yeah?
We can't multiply it by 0.012, right? We divide it by...
Well, we can if we multiply the top and bottom. So what you could do is multiply the top by centi squared and the bottom by centi squared. And here we have meter squared. So on the top we have 0.005 over 0.01 squared. And then these two, I can put this together as c squared, m squared. But I told you that in physics you can write that as cm squared, which is actually what we want. So this is 0.005 over 0.0001. Which is 50. Is it?
Yeah, because it started at 50 and it's going back.
Yeah, but I'm just double checking that I didn't screw up on the way. 50 centimeters squared. So this one's a little bit harder to see. The trick was here. It was useful to multiply the top and the bottom by centi squared. So when we multiply the top by centi squared, we were able to make the centimeter squared. And when we multiply the bottom by centi squared, we can put in this number. Do you understand what I'm saying about the units? I want you to treat the units and the prefixes like you would in math class. Okay? Sometimes you learn these rules in high school, like to go from A to B, you do X. You multiply by 100, you divide by 100, whatever. I don't want you using that, because it doesn't work when you have more complicated problems, okay? I want you to treat the units, the prefixes, like they were algebra terms in math class. Do you understand? Okay. So, what we'll do, we'll have some questions here you can try for a few minutes, and then we'll start the next lesson. And whatever you don't finish, you'll do at home for homework. So you can try these for a few minutes before we start the next lesson. It's just the first page. There's 4 questions to try. You can try the next. Do you want to try these?
How long we begged you for a book, and now you're giving us questions?
Yeah, just like that.
Okay, Chris.
Oh,
Thank you.
Wait, I don't have this one. You did it.
Never.
Oh, this is my new thing. I try to do something new each year. You ever did this?
Fancy.
And you flip over.
Whoa.
You have the answers.
Whoa.
Oh, you actually get the answers now.
And I'll get this link to YouTube videos.
Really?
Yeah.
This is so unfair. I would have gotten a bit.
Who are you looking for?
Yeah, I'm looking for the heater.
I think my students are getting too warm.
Cheers.
give it a try.
We used to argue with that.
I'll leave it for you.
Find them on last year's YouTube video.
Yeah, we take a look for it. If you come late to
Look.
the lesson.
I said it once, and I'll say it again. Sucks to be you.
If we bet anyone $1 million, do not take the bet because it's a scam.
Yeah, no, I only started to do this actually after he's left, because he put the idea in my head. So yeah, it would be a good idea. They're waiting for you soon. But it's not finished. I only have the first semester done. But if you want, actually, I can. I know. You might find having a workbook of questions useful, because if you're doing something in class and you don't have questions to practice, but you know it was something you did.
Yes.
Yeah.
We have the exam papers for 5 last years. We don't have any answers for it.
Yeah, it's really ridiculous.
Which you got.
University.
All right. If you send me an email, I can send you on the PDF of the book. It basically is mechanics, electricity, and materials. So it's worksheets, but you might be able to find stuff in it that could link up with what you're doing in class if you wanted something to practice. Because you have the links to the
This might
solutions.
be too advanced for what we're doing.
Seriously?
Yeah.
Really?
Yeah, so it's really.
Well, then you can use the next semester then. Are you staying or going? What's your plan now?
We'll meet Dr. Lorraine, then we'll head out on a pre-walking tour.
Look, so far these are much better students than last year's. Look at them quietly working.
Give them a week. They get used
Okay,
to it.
I'll let you know in a week how they get on. I'm going to get some coffee. You're heading back out the front. I'll be back in a minute. Don't go anywhere, okay? Ooh, cold outside.